Hi ladies and gentlemen, this is Mr. Green and this is another in my series of recordings for Algebra 2, and this is the last week before our winter break, so we need to make certain you got everything caught up. We're working in, you should be finishing everything in Unit 7. We're working in Unit 8 here, so we need to make certain we're caught up because next week when we come back from Christmas break, we will be doing reviews for the semester final, taking the final in Unit 8, and then taking the reviews for the semester final. So we need to be on top of things here. Don't let things get behind. What I'm looking at today is 8.2, the properties of a quadratic function. We're going to draw some graphs of quadratic functions. We're going to use the vertex form to do that. We're going to write some equations of a quadratic function in vertex form given the graph, and we're going to convert from standard to vertex form in quadratic functions, and then we're going to find some maximum or minimum values in quadratic expressions by completing the square. Okay? So here we go. Vertex form of a quadratic function. It's this equation right here. It's a function. It says a times x, the quantity x minus h squared plus k. Now, if you remember back to the linear equations, the h and the k tell you how far it's being shifted from the parent function. The parent function in this situation is f of x equals x squared. That goes through the origin, the x squared, f of x equals x squared. It goes through the origin and points up like that, okay? So the h and the k tell you how far it's moved to the right and up. Okay, so those are the two values that are going to be your shifters going that direction. Now, a quadratic has something a little bit different in the sense that it has an a value out here in the front, and that's not a slope this time. That's telling you how wide or how skinny the graph is, okay? So that a is going to actually tell you how wide and how skinny it is, okay? If it's a positive a, it will actually point up like a rainbow. If it's a negative, point up like hook'em horns. If it's a negative a, it'll point down like a rainbow. So negative a, rainbow. Positive a, hook'em horns. Okay? So that's a good way of remembering which way they point. If I wanted to graph one, remember this minus h, that's my h value, 4. My k, it would be plus k, so my k is going to be a negative 2. So what have I got? I've got an h of a 2, or h of a 4, and a k of a negative 2. So I'm going to start right here at the origin, because that's my parent function, and I'm going to move over 4, 1, 2, 3, 4, down 2, 1, 2. That is the vertex of this particular graph. That's how you find that. It's really that simple to find the vertex of the graph. Okay? So now, what do I need to do? I need to find a couple more points. Well, since I'm over at 4, I'm just going to go to the next number out, 5. So I'm going to say when x is equal to 5, or finding f of 5, I'm going to find a value. I'm sticking 5 in for x. I'm going to have 1/2. 5 minus 4, which is 1, squared, minus 2. Well, 1 squared is, well, that's 1. 1/2 of 1 is 1/2. So 1/2 minus 2 gives me a negative 1 and 1/2. Well, that tells me that at 5, it's going to be at a negative 1 and 1/2. It's going to be like right there. Well, it also tells me that this one will be here too, because this is an axis of symmetry going up here, meaning that it is symmetrical on both sides of it. Okay, let's try another one. Let's go to f of 6. Okay, if I stick a 6 in there, 6 minus 4 is 2. 2 squared is 4. Half of that is 2. 2 minus 2 is equal to 0. So at 6, it's going to be at 0. That means over here at 2, it's going to be at 0, because remember, it's symmetrical. And we can draw our graph just like that. to-do. Tried to be careful drawing it this time too. That's what your quadratic would look like. Okay? That's how you can use the vertex form, stick a couple points in there, and find the graph, very simply. Well, what if you're given the graph and you're asked to find the equation of the quadratic equation? Well, you can find the vertex. It's right here at 0, 3. That's going to go in for my h and my k, right? So I've got a x minus 0, well, I can just leave that off, squared, plus 3. They gave me another point out here at 2, negative 1. I can stick that in for my x and my y. And my y is going to be negative 1 is equal to a times 2 squared plus 3. Well, I'm going to subtract the 3 from both sides. It's going to give you minus 4 is equal to a times 4. Dividing by 4, I get a negative 1 is equal to a. And that tells me all the values I needed for the function. My function, f of x, is going to be equal to negative x squared plus 3. Wow, little bitty 3. 3. That would be the equation for that graph right there. Hope you see how I did that. I just stuck in these two values into what I knew as the equation. Okay? Let's look at another one of those. Okay, my vertex is at negative 1, 3. I'm going to stick it in for the h and the k. A x minus a negative 1 plus a negative 3. Okay? And this is, when I simplify this out, I get a x plus 1 squared minus 3. And I'm going to now use this other point that they gave me, 1, 5. So 5 is equal to a times 2 squared minus 3. So add the 3 to both sides. I get 8 is equal to 4a. Dividing by the 4, I get a is equal to 2. And I can write my entire equation now. F of x is equal to 2 times x plus 1 quantity squared minus 3. That would be my final equation. Okay? Let's move forward to the next topic here. If I want to take something that's in vertex form and put it in standard form, I have to first of all square this. Well, x plus 4 squared. That's x plus 4 times x plus 4. Okay? Well, I got to use the FOIL method to do this. I'm going to get an x squared plus 8x plus 16. And I will be multiplying this whole thing by 3 and then subtracting 8 from it. So if I multiply the whole thing by 3, I get 3x squared plus 24x plus 30 and 18 is 48 minus 8. So I'm going to say 3x squared plus 24x plus 40. That would be the standard form for this equation. You see, the trick here is, first of all, taking what's in the squared in the parentheses and expanding it. Multiplying it times the a that's in the front, adding the k that's at the end. Okay? Okay. Let's write this one in vertex form, so we're going to go the other way. Now, to do something, we have to do something here called completing the square. This is a process that we go through. To complete the square, the first thing you do is you separate out the x's. X plus 8x. And you separate that out with a parentheses. And you've got the plus 9 here at the end. I know I can stick those parentheses in. They don't affect the value any at all. I'm going to remember that if I had a perfect square, I'd be able to say that b over 2 and squared would be the final term that would be out here, plus something here, right? It'd be b over 2 squared. Well, what's b in this situation? It's 8. 8 over 2 squared. Well, that's 4 squared. That's 16. So I'm going to add a 16 on here, but I just can't just add 16. So I'm going to subtract 16 over here on this side. Can you see how I'm inside the parentheses there? I've done the same thing. I added 16 inside the parentheses, but subtracted it out here. So I now know that what's in my parentheses is a perfect square. It's going to be x plus 4 squared. What do I have outside the parentheses? Minus 7. And that would be my vertex form of this equation. Okay? Okay? Now, this tip down here where they're saying make certain you add it to both sides of the equation. Obviously, I added 16 here. I could have subtracted or added the 16 over here and then subtracted it again. I just went ahead and subtracted the 16 as a duplicate step there. So, it does the same thing. Let's look at this one. I'll try to be more diligent on this one. I'm going to first of all separate out my x's. So, y equals negative 3x squared plus 12x parenthesis plus 5. Well, you know what? Let's just do this. Let's subtract the 5 over here. Y minus 5 is equal to negative 3x squared plus 12x. That makes it a little bit easier to deal with, right? So I'm going to factor out the minus 3 because that's going to get in my way. Y minus 5 will be equal to negative 3 times x squared plus 12, 4. Huh, geez, Mr. Green. Plus negative 4, get my pen back, minus 4x. Okay? Now I got to figure out what to add on there. I'm going to divide by the negative 3. Y minus 5 divided by negative 3 equals x squared minus 4x. And I've got to figure out what to add on here, right? So I'm going to say, let's see here, b over 2 squared is what I want to add on. Well, b over squared, that's going to be equal to negative 4 over 2. And I'm going to square that. So that's negative 2 squared. That's a positive 4. So I'm going to be adding 4 onto here. If I add 4 there, I've got to add 4 over here. Okay? So I get y minus 3 over negative 3, y minus 5, minus over negative 3 plus 4 equals x minus 2 squared. Well, I want to put it back into the right form, so I'm going to subtract the 4 back out over here. I'm going to multiply by the negative 3, so I'm going to get y minus 5 is equal to negative 3 times x minus 2 squared plus 12. Where'd the 12 come from? Well, I had to multiply the negative 3 times the negative 4, giving me the 12. So now when I add the 5 to both sides, I get y is equal to negative 3 times x minus 2 squared plus 17. That becomes my vertex form that I was looking for. Okay? Cool. Hope you can follow that. We're going to be doing some of that over the next couple of weeks, so you need to make certain you understand how to complete the square, these things. Okay, quadratic functions. They are a part of that y equals x squared family, which is that graph that makes the horseshoe or the rainbow, depending upon whether it's got a positive or a negative a in front of it. Right? The shifts h and k shift it right and left and up and down. And the a will determine the value of the a, the absolute value of the a, tells you how wide it is or how skinny it is. The smaller the a, the wider it is. The bigger the a, the skinnier it is. So it gets much, 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 much skinnier. Okay? So you just need to be able to keep track of these things that are causing the shifting on this one. The A will either make it be a horseshoe or a rainbow. It will also determine width. Okay? The H, right or left. And the K, up or down. Those are the things you need to keep in mind when you're doing this, okay? Okay. Let's see here. What else we got? Oh, yeah. We're going to do a couple more of these that are just going to convert to vertex form. And I'm going to do these relatively quickly, okay? In this situation, you know what? I'm going to subtract the 4 from both sides. And then I'm going to have x squared minus 4x over here. And that's minus 4 over 2 squared is equal to negative 2 squared, which is a positive 4. So I'm going to add a 4 on here. And what am I going to get? I'm going to get a y minus 4 is equal to x plus a negative 2 quantity squared. And I'm going to get a y equals x minus 2 quantity squared plus 4. That would be vertex form. On this one over here, same thing. Y minus 25 is equal to 2 times x squared plus 12x dividing by the 2. Y minus 25 over 2 is equal to x squared plus 12x. Let's see here. 12 over 2 is equal to 6. Squared is 36, so I'm going to add 36 on this side and add 36 on this side. So what am I going to get? I'm going to get a y minus 25 over 2 plus 36 is equal to x plus 6 quantity squared. Okay, so I'm going to subtract the 36. Y minus 25 over 2 will be equal to x plus 6 quantity squared minus 36. Multiplying through by the 2, I'm going to get a y minus 25 is equal to 2 times x plus 6 squared minus 72. Adding the 25, y equals 2 times x plus 6 quantity squared minus 60, 57, 47. And that would be my vertex form. Okay? Now, I'm going to recommend you guys watch me do that several different times. Go through the video a couple times if you need to. Back it up, watch it again, because that will help you understand how to convert these into vertex form. Okay? Cool. Well, that's the end of the lesson for today. I do appreciate you guys making certain you're always telling me you're in Algebra 2. It does help me. It does help me understand who I'm talking to sometimes and find your information. I'll look forward to seeing you next time.